In the universe, there are places you can never reach, and there are things you cannot even see. The scariest black holes are not terrifying because they swallow things. They are terrifying because they force us to admit something uncomfortable. There are regions on the cosmic map where physics becomes a matter of speculation. There are objects that look like black holes but have no event horizon. And there are real black holes that only show up as a signal in space-time. Stay until the end of this video, and you will see the 3 twists that make black holes truly frightening. First, the fake thing we mistake for real. Second, the real thing that is almost invisible. Third, the thing that pushes modern physics to its limit. Today, this video takes you through a tier list of the most terrifying things around black holes. From Tier 0, black hole impostors, all the way to Tier 6, ideas at the edge of our current model. In every tier, I will show you 3 things that break intuition: what it is, why is it scary, and what signal proves it is there. How do we verify it? With light, with orbits, with X-rays, or with gravitational waves? Because in science, some things exist on paper for hundreds of years before humans can measure them. Black holes are exactly like that, so not proven yet does not always mean not real. Sometimes it only means we do not have enough signal to conclude. Before we explore real black holes, we need to talk about the fake ones. Tier 0, black hole impostors. There are ultra-dense objects that can mimic a black hole almost perfectly, but they are missing one key feature: the event horizon, the point of no return. Here's the scary part. If we get it wrong, what we call a black hole could be something completely different. First, neutron stars, the dead core of a star, crushed to an extreme. City-sized, yet heavier than the sun. Its gravity bends space-time right next to it. When a neutron star spins, it becomes a pulsar. It sweeps a beam like a cosmic lighthouse. And when it reaches an even more extreme state, it can become a magnetar. A magnetar's magnetic field is so powerful that it can violently affect matter and plasma around it. Sometimes it fires intense flares in X-rays and gamma rays, but that's just the warm-up, because there is an imposter that can fool you even harder, an object that is almost the right size for a black hole, yet has no event horizon at all. Ideas like gravastars and boson stars suggest something wild. There could be objects that look almost identical to black holes, but without an event horizon. If that is true, then every time we say, "this is a black hole," we would have to add one more sentence. Either it is a black hole, or it is a perfect disguise. And the most important question becomes this: if there is no event horizon, does the object respond back to the universe? Does light bounce out? Do we see a tiny echo in gravitational waves? Tier 1, primordial black holes. Tier 1 is primordial black holes. These do not need a star to die. They could have formed right after the Big Bang, when regions of extreme density collapsed under their own gravity. They are not the remnants of stars. They could be relics from the first moments of the universe. What makes them scary is the mismatch in scale. They could be incredibly small but carries an enormous mass, something too small to see but as heavy as a mountain. And here is the most controversial part. If enough of them exist, they could make up part of dark matter, the missing mass that holds galaxies together. The problem is that we can almost never see them directly. We can only hunt them through gravity, like microlensing, or rare signals when they interact with their environment. And because they can be so small, they might evaporate through Hawking radiation, meaning some black holes might disappear, like a brief flash deep in the dark. Tier 2, stellar mass, black holes. Tier 2 is where black holes become the real thing. They are born from the death of massive stars. A giant star collapses. Its core compresses. A few dozen suns worth of mass gets packed into a region the size of a city, sometimes just tens of kilometers across. You do not see the black hole itself. Because it does not glow, you only see what it makes glow. It is scary because it is common. There could be millions drifting through the Milky Way. Many of them are quiet, not feeding, and almost invisible. So the question is not whether they exist. The question is whether we can catch their signature. Cygnus X1 became an icon because we inferred a black hole from X-rays produced as it pulled material off a companion star, forming a blazing hot accretion disk. Then LIGO gave us a shock. Space-time itself rang when 2 black holes merged. That was the moment the universe spoke. Tier 3, intermediate mass black holes. Tier 3 is intermediate mass black holes, roughly 100 to 100,000 times the mass. For a long time, we only saw two ends of the spectrum, stellar black holes on one side, supermassive black holes on the other hand, but between them was a gap, and whenever data has a gap, science has to ask, is something missing in the middle? Intermediate black holes are the proposed missing piece. They are scary because they are big enough to dominate a region, yet quiet enough to hide. They do not easily accrete. They do not easily shine. They are like a predator you cannot see. You only notice a star's orbit pulled off course, or a brief flare when a star gets ripped apart by tidal forces. And it is possible these objects are the foundation that builds Tier 4. Tier 4, supermassive black holes. Tier 4 is supermassive black holes. They do not just swallow, they are the gravitational anchor at the center of a galaxy. Our Milky Way orbits Sagittarius A star, Sagittarius A star. In other words, we live inside a galactic city that circles a dark abyss at the center. When a supermassive black hole feeds intensely, the galaxy's core can ignite into a quasar, a lighthouse so bright it can outshine the entire host galaxy. If a quasar is close enough, its radiation could strip the atmospheres and make a planet's surface hostile to life. Its jets can push, heat, and stir gas across hundreds of thousands of light years, shaping the evolution of the entire galaxy. But the most terrifying part of Tier 4 is not power, it is timing. How did these monsters already exist when the universe was still young? It is as if nature had a shortcut to build supermassive black holes faster than our growth models predict. And if you want a case that feels almost haunting, you have to hear this name, Ton 618. Ton 618 is an ultra-bright quasar powered by a black hole estimated at around 66 billion solar masses. But the unsettling part is not just size, it is its position in time. You are not just looking at a place, you are looking at an era when the universe was still young. And Ton 618 stands like a challenge. How did anything manage to feed this thing fast enough? It is not just a hole, it is a massive question mark hanging over our best growth theories. But we still have not reached the scariest tier. Because the scariest thing is not size. It is when a black hole becomes something you cannot see at all and can only hear. Tier 5, mergers and gravitational waves. Tier 5 begins when two black holes lock into orbit. They spiral closer, they move faster, until they merge. In the final moment, just a fraction of a second, the universe releases gravitational waves. Not light, a ripple moving through space-time itself. And we've heard it. Every detection reminds us there are events so violent out there that even space-time has to ring. Tier 6, the edge of the model. Tier 6 is the boundary, where our current model starts to thin out, and science has to admit the truth. We are not sure. First, naked singularities. A singularity without a horizon. If they exist, they could be places where our equations stop controlling reality, where causality and time become hard to predict with familiar physics. Then there is the white hole. In theory, the opposite of a black hole, something that only ejects and never allows anything to enter. It sounds like science fiction, but it appears in certain mathematical solutions in general relativity. And finally, gravastars return to the conversation. If something can look like a black hole without an event horizon, the problem is not just labeling. It is our definition of a black hole, and everything we infer from it might need to be rewritten. The scariest part of Tier 6 is not that it threatens your body. It threatens the idea that the universe can be fully understood with the tools we currently have. So what is the scariest thing about black holes? Not that they swallow, but they force a harder question. Is what we are measuring really a black hole, or a perfect impersonator? Which tier felt the most terrifying to you, and why? Comment the tier number. I really want to hear your take. And if this video hit you, share it and subscribe so you do not miss the next one.